Yes, dear students, now I want to discuss here photoelectric effect. Photo means light, electric effect. I will discuss it here. Many theories are there from the starting. J. Thomson discovered electrons through electric discharge through gases. Before that, many people did lot of work. In 1898, J. Thomson discovered electron. And now we are well aware of the fact that metals have free electrons. Those free electrons are there due to the metallic bond formed to form the metal crystal. The valence electrons possessed by atoms are lost to the metal crystal and positive ions are there. The number of free electrons is very large and there will be positive ion arrangement to three type of interaction take place: repulsion, repulsive force between electron between positive ions, and attractive force between electron and positive ion. Electrons are very big number, we say electrons is there. Those electrons are free to move inside the metal but cannot leave the metal surface. They can leave the metal surface if some energy is supplied to them. So that way emission of electron from metal surface can take place in three different ways. Thermionic emission. If we heat metal surface here by some heater, electrons come out. We now know electrons are negatively charged, so they leave behind positive charge on the metal, so they are pulled back. So a large number of electrons are created if we heat the metal surface, and a net negative charge appears here. This is called. If we want to make the move, we use other plate and apply potential positive and they start going. Initial electronics were based on this thermionic emission. Thermionic. It's just simply just introduction. Then field emission. If we apply this metal surface and here we apply electric field of 10 to the power 8 voltmeter, then electron may be taken out from the metal surface. So this is called field emission. The third is photo emission. So actually discovery, there are many things to tell, but I am in brief here. I want to discuss only photoelectric effect. Heinrich Hertz. Though many will work on this, but Heinrich Hertz is supposed to be the discoverer or inventor of photoelectric effect. In 1887, discovered that when high frequency radiations like ultraviolet rays, or visible light is incident on metal surface electrons are emitted. This phenomena is called photoelectric effect. Photoelectric effect. The electron emitted are called photoelectrons. The photon emitted, these are called photoelectrons. This was, so later on he discovered this, but now man will work and measure different things. Here it is a diagram, modified diagram of apparatus used to study photoelectric effect. Actually Halbach. Some people speak Halbachs. CHS, Halbachs and Lenard. Studied the photo effect and measured many things, and the observation made by them are now called laws of photoelectric effect. Now what is this? It is a highly evacuated glass tube. Here is a window. From this as the source of radiation, from which radiation are allowed to fall on this metallic cathode. We can change this metal here at cathode. This is anode. There is no air, vacuum is there only. And this is called metallic anode. We can apply a potential difference. What is this? This is commutator. What is commutator actually? Anode is given positive potential, but here we can change this anode potential, and this is cathode. So here the battery rheostat connected in parallel, which acts as potential divider. This potential divider. So this current will keep on flowing here. So IR, potential difference this much, will appear across these 2 points. If we connect this terminal here and this, this here, so anode become positive potential, and this here negative. Or if we invert them, we can give negative anode voltage. S is the source of light. Here the microammeter measures the current which flow in circuit in some condition. As source of light or radiation. If we change the distance of source from cathode, please note it very carefully what I am saying, because I am going to tell you something other thing. For competition point of view, for exam point of view also. But I have to make everything clear. Source of light. If we increase distance from the cathode, intensity of radiation falling on cathode changes. Actually intensity of supposedly point source here, whose power is P. And at distance R, actually the total energy emitted per second will be spread in this area. And intensity is the amount of energy crossing unit area per unit time. So that comes P upon 4 pi R square. If R is increased, suppose R becomes double, so intensity become 1/4. If we bring the source closer, intensity will increase. So by changing the distance of source S, we can change the intensity. Now, if we want to change frequency of light or radiation falling on this, then we have to change the source. Suppose sometimes it is ultraviolet light, sometimes it is blue light, sometimes you can use yellow light, red light, etc. We can change the metal anode cathode because to study the effect on different metals. When actually radiation fall here, electrons are emitted. Those electrons they go in the direction, but here we create positive potential, so they are attracted and they start moving. As they move, when light is falling, electrons are moving and current flows in the circuit. If we stop the radiation falling on cathode, no current will be there. You know I is equal to Q by T or Q equal to NE by T. So we can measure the rate of number of electrons coming out per unit time on anode by measuring current by ammeter. This is microammeter. So by measuring current, this is also called as photoelectric current. We can measure number of photoelectrons coming at anode per unit time. Now, it has been observed there when anode is even at zero potential, electrons are reaching and current flows in the circuit. So, if we give anode a negative potential and increase the value from zero onward, then at certain voltage, at certain negative voltage of anode, at certain negative value of anode voltage, photoelectric current becomes zero. Means no electron reach here. Why? Actually, electron has negative charge, and when we give negative potential here, so they are repelled. And you know, by definition of potential difference, V equal to W by Q. So W equal to V into Q. Charge of electron minus E and minus V is the voltage. So E into V will be the work done in moving this against negative potential. At certain negative potential, current becomes zero. Means electrons are not able to reach, they come back. And that potential, that negative potential anode at which current becomes zero is called cutoff potential. By measuring cutoff potential, we can measure maximum energy of electron, K maximum. Because here electrons are emitted of different kind of energy. So I hope you have got all these clear. Okay, number of photoelectrons emitted measured by measuring current and kinetic energy of electron measured by knowing the cutoff potential, negative anode potential. Now I come directly to the observation of Hallock and Lenard, or which are called also as laws of photoelectric effect. I hope you have got this diagram. I can rub this, or you can read this diagram from different books also. But please, in board exam, so this diagram is generally asked to draw the diagram which is used to study photoelectric effect. So what was first observation? What is first law? So number one, the number of photoelectrons emitted by photocathodes per unit time is found to be directly proportional to the intensity of radiations falling on photocathode. Number of photoelectron falling or emitted per second, which is measured by measuring photoelectric current, is equal to intensity of radiation falling on photocathode. If keeping the frequency of radiation same, we plot the graph between anode potential. Here this is anode potential. In volts only. 1, 2, 3, 4, 5. -1, 1, 2, 3, 4. -2, -3, etc. And here we take photoelectric current. Photoelectron measures the number of photoelectrons. So at one intensity, the graph may be obtained like this. And I told at zero potential, there is current this much, and it decreases as anode potential made more negative, more and more negative. It is supposed at intensity high. Now the current does not increase after certain value of anode voltage. Why? Because as many electrons are emitted, same are collected. For other high, if we keep the frequency same, so this graph comes the same I2 or I3. Here I3 greater than I2 greater than I1. This value of current here is called saturation current. So number of photoelectrons emitted per second is measured by measuring saturation current. And here you can see also one thing more. If I take intensity this way and number of photon, intensity of radiation, and number of photoelectron. So this graph may be like this. Provided emission taking place, this negative value of voltage called threshold potential, and I told you threshold potential multiplied charge of electron gives us maximum kind of electron. So here from this graph we say that number of photoelectron that is proportional to intensity of radiation. Frequency does not matter. Now number 2 observation. Number 2. The maximum kinetic energy of photoelectrons is directly proportional to the frequency of radiation, and also depends on the nature of metal used as photocathode. जो मेटल होगा उसकी नेचर पर भी डिपेंड करेगा. And if we plot here a graph again between anode potential and node potential, taking volt and photoelectric current, then keeping intensity same, changing frequency at low frequency and intensity same, I here the cutoff potential. If we increase frequency, it is new one. If we increase frequency, then cutoff potential increase new 2. So this indicates that higher the frequency of radiation falling, here nu 2 greater than nu 1. If you take more, so it can go further. Nu 3 greater than nu 2 greater than nu 1. So kind energy depend on frequency of radiation and nature of metal. The minimum energy required to emit the electron from metal is called work function of metal. Also, I will be discussing here. So this is the second observation का कि number of kinetic energy of maximum energy of electron depends upon rise proportional to frequency of radiation and nature of metal. Number 3, for every metal there exists a lowest frequency below which no emission of electrons will take place. This frequency, this lowest frequency, is called critical or threshold frequency. Here we can understand here like this. If we plot the graph between, if we plot the graph between kinetic energy of photoelectron, maximum energy, and frequency of light, we have wrote 10 to the 14 hertz frequency nu. Then for different metals taking at photocathode, we get the graphs like this. If we produce back, it cut here. For metal 2, it may be like this. For metal M1, for metal M2. This much negative value actually for function of metal 1. This is for metal 2. The graph come parallel to each other. Measuring the slope, we can measure the value of minimum energy required for required to eject the electron from metal. And the slope, in fact, of this graph will come. You will come to know is equal to Planck constant H. I will discuss later on. Now, last and fifth observation, that is very important also. If the frequency, these are mu1, mu2 are the threshold frequencies, cutoff frequency. If the frequency of radiation is above the critical frequency, then there is no time lag between emission of electrons and incidence of radiations. There is no time lag, means as soon as radiation fall, electrons are emitted at once. So these are 4 observations or 4 laws of photon effect. In next video we will discuss how this phenomena is taking place, what theory will explain this phenomena. Video has become a little lengthy because I wanted to discuss all these things together in one video. Thank you. Meet next video.